started. We are going to do 6.8 today, which is talking about the increasing and decreasing in some piecewise functions, which means functions that have different pieces. So on the graph, sometimes they'll be increasing, sometimes they'll be decreasing, sometimes they'll be constant, which means just straight across, okay? So we're gonna be looking, first of all, on the first problems, it's gonna give us a function, and the function's gonna have three separate pieces, okay? So the way that's gonna look, oh, way off. Hang on, let me pause this for a second. Okay, so here's what a piecewise function means, okay? And this just means depending on where you are on the graph is going to be doing separate things. Like here, like the first part may look like this, and then there just may be something that looks like that, and then something constant. It just depends on where you are on the graph. On what it's going to look like. So that's why it's split up into different pieces. So the way it's written out, it's for 8x. It's for all the x's that are less than -3. The graph will be in the shape of x squared when the x's are between -3 and 4. And then the graph will be x minus 6 for all the x's that are greater than or equal to 4. Okay? So this says the piecewise function is defined as shown to the right. Identify the expression that should be used to find f of -7. So what it wants you to do is find this number and which section it should be in. So is -7 less than -3?
Yes.
It is less than it, right? Which means that for -7, you are going to be in that piece. This number will only fit into one of these. Okay, so since this -7 fits into the less than -3, that means the -7 is going to go in the 8x piece. So right now, we're just finding which piece it'll go in. At the end, we're actually going to kind of work this section front and middle. We'll actually be plugging in that number. So for right now, all you're doing is finding what piece -7 would go in. And since it's less than -3, it's going to go in the 8x piece. Okay, number 2, same kind of thing. Again, the first piece is 8x for when x is less than -3. I think that's just like the last one. X squared. Oh, this is almost for -3 is less than or equal to x is less than 1. And x minus 5 for when x is greater than or equal to 1. And this time it wants us to find what piece f of 9 would go into. So let's see, this time our number is 9. Is 9 less than -3? No, bigger than -3. So it's not in this piece. Is 9 in between -3 and 1? 9 isn't between those two numbers.
No.
Is 9 greater than or equal to 1?
Yes.
9 is. 9's bigger than 1. So that means 9 would go in this piece. And what is that piece? X minus 5.
Ms. Hanson, what worksheet are you working from?
6-8. Look like that. Yeah, we did 6-1 Monday. We'll do 6-8 today. And we're going to do 5-4 on Friday. All right, number 3. Let's look at the pieces for number 3. Number 3, the function is 4x for when x is less than -5. X minus 3 for when -5 is less than or equal to x, which is less than 2. And it's x squared for when x is greater than or equal to 2. And it was to find what piece will f of 2 be in. So you're going to have to be careful on this one. All right, 2 is 2 less than -5. No, it's bigger than -5. So it's not in this first piece. So this says x is greater than or equal to -5 and x is less than 2. So that means it's in between the -5 and the 2. Okay, but look, 2 is in both of these pieces. That means I need to, and since I'm looking for 2, I need to find the one where it's going to equal 2, right? This says x, this piece, this little spot right here says x is less than 2. Is this less than 2?
No.
No.
Equal.
This right says, this one says x is greater than
Equal.
or equal to 2. Which means what? 2 goes in this piece because that's where x equals 2. And what is that piece? X squared. Okay, here's what I mean by jumping around. We're going to come back to number 4. We're going to actually go to the last 2 problems, number 10 and number 11, because they just naturally come right after this. So go to number 10 if you have your worksheet out. So these are actually going to give us the function and tell us to find f of 2, which means go find its piece and then take it one step further by plugging it into that piece. So let's see how that looks. All right, here's the function. G of x equals x plus 7 for when x is less than or equal to 3, and it's 4 minus x for when x is greater than 3. And it wants us to find 3 different things. The first thing we're going to find is g of -3 3. So we need to go find what piece that fits into and then actually plug it into that piece. So let's see, g of -3 is -3 less than or equal to 3. Is -3 less than 3? It is, right? -3 is less than 3, which means it goes in this piece. What is this piece? X plus 7. So it wants me to actually replace the x in that piece with that -3. So that's what taking it a step further is going to do. You're going to find what piece it goes into. So since -3 is less than 3, that means it goes into this piece, and this piece is x plus 7. So replace the x in this piece with that -3. So when I do that, I'll have -3 plus 7, which gives me 4. Same problem, but this time it wants me to find g of 3. So you have to be careful on these, right? X is less than or equal to 3, or x is greater than 3. It's only going to fit in one piece. It's not going to be able to go into two separate pieces. So I need to find where g equals 3, right? Or where this right here. So does 3 equal 3? Which means, again, it goes in this top piece. What is the top piece? It's x plus 7 again. So I found its piece. Now I'm going to replace that x with a 3. So I'll have 3 plus 7, which gives me 10. Then the last one on this problem says find g of 4. So go find, first of all, what piece 4 is in. So is 4 less than or equal to 3? It's not, it's bigger than 3. So 4 is greater than 3. So it goes in this piece. What is that piece? It's 4 minus x. That's the piece I need to plug it into. So what am I going to replace this x right here with? 4. 4. So I have 4 minus 4, which is 0. Well.
So what are those two things like? What? So is the greater on that x is greater than 3?
Correct.
And that one is x less than or equal to 3?
Right. You can't be in both, right? You're either less than or equal to it, or you're greater than it. Do you see there's not a number that could go into both pieces?
Oh, okay.
You're either one or the other.
Okay.
Right? There's all the numbers less than 3 and 3.
Okay.
The other group is all the numbers greater than 3. So you're either going to be in one group or the other. You can't be in both.
I still don't.
Right? So any number that's in here, there is absolutely no way that you could be in both of these groups. You're only going to be able to be in one of them. Because look at the number line. So if there's 0, there's my 3. So you either equal 3 and less than 3. So that would include this and everything below it, right? Any number below 3 or actually 3 is what this says.
Less than or equals to?
Yeah. What does this say?
Greater than.
Which would be the other side of 3, not including 3 because it doesn't have the equal to.
Okay.
Right? So you're either in this group or you're in that group.
Okay, I got it now.
Okay, let's look at number 11. So there's three pieces to this function. Negative 2x minus 18 for when x is less than negative 6. It's 1 for, oops, negative 6 is less than or equal to x, which is less than 1, and x plus 6 for when x is greater than or equal to 1. So this one actually has three pieces. Okay, I'm going to draw this one out on the number line to show you the three pieces. Okay, this isn't something you have to do. The numbers I'm going to have are the number line are this negative 6 and 1. That's going to separate your three pieces. So there's 0, which means there's 1. There's negative 6. So let's look at the first piece. What does it say? X is less than 6. So where would that be?
Okay, pause, Miss Hanson. I'm looking at 6.8, Miss Hanson. Well, my 6.8 don't look like the 6.8 you doing.
Really?
Yes, my 6.8 looks like h of x, and then it has negative 5x minus 8, then it has 3 comma, then it has x plus 1.
I
and then
understand how that's happening because I'm literally, when I go and I save it, I immediately send it to y'all. I don't know what is happening. So it's the same time, just different numbers?
Mine says 2.
Is
I'm looking.
Your number 11 looks like this, but these numbers are just different?
Yes.
Okay, then just mark yours out and put mine. It's the same kind of problem. It's going to give you the same instructions. The numbers are just going to be different. So just exit out and put mine that I'm working.
Okay.
I cannot figure out why that would be happening. I'll have to look into that.
Okay.
So x is less than negative 6 would be all the numbers on this side is negative 6, right? Let's see. This middle piece, here's where you got to be careful. Trying to find a different color. This is where you're going to be x is greater than or equal to negative 6. So that's the one that includes the negative 6 in it.
Reading? What reading? What?
So it includes the negative.
Let me get up.
And x is less than 1. So not including 1, right? Not x equals 1. X is less than 1. So that includes those numbers here. And what's the last piece include? When x is greater than or equal to 1. So those are your three pieces that are happening. It wants us to find h of negative 8. So where would negative 8 be? In this piece right here, right? Less than negative 6. It wants us to find h of negative 1. Where would that be? It'd be in this piece right here, right? Here's negative 1. It's going to want us to find h of 1. So 1, this is the one where we're going to have to find the equal to 1, right? Because that's like the border of one of the pieces. And h of 5. So those are my 4 numbers that I'm going to find. And the pieces that they're going to go in. So let's do negative 8 first. So is negative 8 less than negative 6?
No.
Is it?
Yes.
It is. Mm-hmm. If negative 6 is here, negative 8 is here. So this negative 8 is less than negative 6, which means it does go in this piece, right? Negative 8 falls in this piece, which means I'm using this. Negative 2x minus 18. So I'm going to replace that x with negative 8. So I have negative 2 times negative 8 minus 18. Negative 2 times negative 8 is
16.
16 minus 18 gives me -2. So -2 is that answer. I'm going to find h of -1. So let's see, is -1 less than -6?
Yes.
Look at the number line. There's 0. There's -1. There's -6.
Oh.
So is -1 less than -6? If it was less than -6, it would be to the left of it on the number line. All the numbers less than -6 are down here. So -1 is not less than -6. Is -1 in between -6 and 1? Well, here's -6. There's +1. There's where -1 is. Is it in between those two?
Yes.
It is, which means -1 goes into this piece. Here's the tricky part of this. If you're in this piece, what is your answer?
1.
It's just 1. There's not an x to plug into. Your answer, if you are in between -6 and 1, your answer is just plain old 1 every time. There's no x to plug into there. All right, let's go find what piece? h of 1. So I'm looking where 1 goes over here. Not less than -6. Look, it's in both of these. So now what am I looking for? If I'm finding h of 1, I need to find the piece that says x equals 1, which is this bottom piece, right? So this is the piece I'm using, which is x plus 6. And replace your x with 1, so you have 1 plus 6, which is 7. And the last one, h of 5. Five is not less than -6. It's not between -6 and 1. 5 is greater than 1, right? Well,
I was going to answer that.
oh, you are, sorry. So 5 is greater than 1, right? Which means it's in this bottom piece, which is x plus 6. Replace your x with a 5. So 5 plus 6, which gives you 11. Okay, so that was the ending 2 problem. So now let's go back to the middle.
So we were on number 10 and 11?
That was, yeah, we did 1, 2, 3, and then we did 10 and 11. Now we're going to go back and do 4. Okay, so this is what piecewise functions look like on the graph. So do you see, just the graph isn't the same on the whole graph. There's different things happening depending on what part of the graph you're on. The whole function's different. Okay, so let's look at what this looks like. We're going to talk about increasing and decreasing now. So I'm going to draw out number 4. Okay, it's going to want to know three things. It's going to know where is this graph increasing, where is it constant, and where is it decreasing. So let's label the graph in these three different kinds of deals. You're decreasing when you're going down. You're constant if you're going straight across. And then you are increasing if you are going up. So this is the portion of the graph that is going down. So that's your decrease portion, or interval. We'll call it an interval. Going straight across here. So this is where the graph is constant. And then it starts going up right here. So it's increasing. When you're talking about, and these are all going to be answered in interval notation. So all the parentheses with the beginning spot to the ending spot. A lot of times you'll see negative infinities and infinities, things like that. Okay, we're going to use, here's why I put points in these two spots. Okay, even though they don't have actual points, they make it very clear where that is. Do you see where that is at? That X is at -4. And then it goes here, that X is +4. The reason I'm talking about the X's is because that's what you're going to use when you're talking about increasing and decreasing when you're naming the intervals. You're going to name the points at which that changes. So let's see, where is it increasing? It's increasing starting here. And then it goes up and to the right forever, which means it increases to infinity, right? That's what this arrow means. It goes forever. So what is the X coordinate of this point? That is where it starts increasing. That's going to be your starting thing in your interval. The X here is +4, right? Where it lines up with the X is 4. So it's going to increase from 4 to infinity. So the way I would write that is in interval notation. Infinities always have parentheses. This parenthesis means I do not want to include 4 in my increase, because what's actually happening at 4? It's actually not constant or increasing. It's where it's stopping one part and starting the next. Okay, it doesn't actually go in either category. That's why you put a parenthesis around the 4. When you're talking about increasing and decreasing, you're always going to use parentheses. Okay, the constant. Here's my constant interval, which means it starts being constant here, and it stops being constant here. So what is that interval? Using the X coordinates. This one is
-4 to 4.
-4, and it stops being constant at +4. And then the decrease. Here's my decrease interval. This one's a little bit trickier, because this -4 is where it what? Where it stops decreasing, right? That's its end. So it ends at -4. What does an arrow going this way mean it's going to? Good, negative infinity. So it starts at negative infinity. Then it keeps decreasing, decreasing, decreasing until it gets to -4. So -4 is its stopping point, because then it goes constant. So those are your 3 different sections. All right. Number 5. So for those of you that did the support on Monday, remember we did this over and over. So let's look at the graph of number 5. Okay, so just so it's clear, I'm actually going to go through to each one of these points and name its x coordinate, right? Because that's what we're going to use to name our intervals when we are talking about increasing and decreasing. This one's x. Okay, so I just went through those numbers that are by those points are the x coordinates of each of those points. Because that's what we're going to use when we're talking about the different intervals. Now let's label each section and what's happening. So this one, what is happening here? Are you increasing, decreasing, or constant? You're constant here. What about this one? You're increasing there. What about this one? Decreasing. You're decreasing there. And what about this last interval? Another increase, right? You're going up again there. This one wants to know increase, decrease, and constant. So let's see, where is it increasing? It's actually increasing on two different intervals, right? So we're going to have two interval notations here because it's increasing in two different spots. So let's see, using the x coordinates that I put up there, where is this one increasing from? Where does it start increasing? It starts at -5. And it increases until it gets to this point, and that x coordinate is -1. So there's the first increasing interval. Got another one. There's another increasing, right? That's another area that it's going up. Where does it start going up? Where the x is 5, and it goes up until the x gets to 8. Using x coordinates every time. So there's the increase. Where is my decreasing interval? It's this interval right here. Where does it start decreasing? Where the x is 3. And it goes down all the way to this point, and that's lined up with the x being 5. So it decreases between 3 and 5. And where is it constant? This one right here. So where does it start being constant? At -8 until it gets to -5. Okay, let's look at number 6. Okay, so once again, I'm going to name the x coordinates at all those special points, the points at where it's changing directions, right? Because it's going to increase until it gets to this point. So let's look at what the x coordinate is of that point. It's lined up with this right here, negative 1, 2, 3, 4, 5, 6. So that x is negative 6. Now I need to know the x's of these points. This x, this point, is lined up with this x. So its x is negative 4. This one's x is negative 1. And what is this last one's x? Its x is 0, right? It's lined up with the 0. So now you know your x's, which is where the intervals change course. Now let's label each one what's happening. What's happening here? It's increasing. It increases all the way until it gets to this point, and then it turns around and goes down. So then it starts to decrease. Then once it gets to this point, what happens? It turns constant. It's constant until it gets to this point, and then it goes back up. So there's another increase. It increases all the way until it gets to this point, and then it's constant again. So there's all the different changes. Let's see, what order? Increase, decrease, constant. So the increasing, I'm going to have two of them, right? Here's an increase. And then here's another increase. Now that I've labeled my x coordinates, that makes this a lot easier. So let's look at this one. It increases from where? Where do arrows going this direction mean? It starts at negative infinity, and where does it stop going up? Negative 6. So there's my first increase. There's another increase, so let's talk about that one. Where does this one start increasing? Negative 1, and it goes up until it gets to the 0. Right? Remember, you're using x coordinates here of each of the changes. Decrease. There's only one place that it's going down. So where does it start going down? It starts going down at negative 6 until it gets to negative 4. So there's the decrease. And constant. How many constants are there? There's a constant here. And then there's another constant here. So there's going to be two constant intervals. So let's see, where does this one start being constant? Negative 4 until it gets to negative 1. There's my other constant interval. Where does it start being constant? 0, and it's constant forever to infinity. All right, number 7. Here's the function. F of x equals negative x squared minus 11x minus 27. Here's what it looks like on the graph. Upside down parabola, right? Because it's x squared and it's negative. And then it tells you what this point is right here. That's what those numbers mean. That point is at negative 5.5, 3.25. So sometimes, so this first question, it's going to ask me, does this one have a minimum or a maximum? What is this point? Is it its top or bottom? It's its top, right? So it's its maximum. Then it's going to ask you two things about the maximum. It's going to say, where does the maximum occur? At what x? And has a value of blank. When you are talking about the value of a point, you are always talking about its y coordinate. That's going to be its value. So that's where those two numbers are going to come in place. Where does the maximum occur? It occurs at x equals, you literally just name your x. So it occurs at negative 5.5. And its value, the value is always talking about the y of the point. So its value is 3.25. And then the last part wants to know, where is it increasing and where is it decreasing? So this is the side that's going up, so that's its increase. It increases until it gets to this point, right? And then what does it do? Once it gets to the other side of that point, starts going down. So it starts decreasing. So let's name these intervals. And what coordinate are you using when you're talking about increasing and decreasing? You're always using the x. So let's see, what are arrows going this way mean? Where is it starting to go up? It starts to go up forever to the left. So that would mean it starts to go up at negative infinity. Where does it stop increasing? Negative 5.5. What happens at this point? It starts to decrease. So where does it start decreasing? At negative 5.5. And it increases, if your arrow is going to the right, that means it's increasing to infinity. So it increases until it gets to this point, and then it decreases. All right, two more.
I don't want to like rush it, but we only have like 4 minutes left of class.
I know. So I'm going to get it in. If you have another class that starts at 10 and it's across campus, feel free to.
No. My class is until like 12:50.
Oh, okay. All right. So I'm just going to name the important. I'm just going to draw this one out. And then they name the coordinates of those 2 points. And they say this point is at negative 8, negative 1. This point is at 0, negative 33. So this one has a relative maximum here, and a minimum here. So my maximum, now remember, it's going to say is blank, that first blank is talking about its value, because then the next blank says at x equals blank. guess it's the same. And then it's going to ask the same thing about the minimum. The minimum is what? And it occurs at x equals what? So here's my maximum. What's the maximum value? What is the maximum? When you're talking about the maximum, you're talking about the y coordinate. So my maximum value is -1. And this kind of also gives you a clue because the second blank actually says x equals blank, right? What is the x here? -8. What's the minimum value? What's the lowest? -33, and it occurs at x equals 0. And then it's going to want to know increase and decrease. So I am increasing here. So this is an increase. I get to the top and then I go down. And then once I get to this point, I go back up again. So there's going to be 2 increasing intervals and 1 decreasing interval. Remember, when you're talking increase and decrease, we're going to use the x coordinates. So let's see, if the arrow is going to the left, where does that mean my increase is starting?
-infinity.
Right, -infinity until it gets to this point. So it increases until it gets to -8. Another increase. Where does this one start increasing? 0. And what do arrows going to the right mean? Infinity. Where is the decrease? Where does it start decreasing? So here's my decrease interval. From -8 to 0. Okay, and I'm going to throw the last one up here real quick. It's a multiple choice. Again, I'm not going to draw a bunch of hash marks. It tells me the important points that I need to know. All right, so I'm going to name this point. My x coordinate is 0. My y is 1. This point is at 2, -3. So, and it's multiple choice, and it wants to know where are the maximum and minimum. So here's my maximum. What is the maximum value? What's the maximum value? 1, and it's where? At x equals what? 0. Where is the minimum? What's the minimum value? -3. And it occurs at x equals what? X equals 2. So the minimum and maximum are always the y coordinates. And then the other part always says where, and it occurs at x equals blank. All right, I got Weimer, Wilson, Chora, Hines, Ecker, Rowe, Morrison, Bennett.
Todd. 415-015.
Taylor's, Keys, Hauser, and Todd. Okay, I think I got everybody. Okay, so again,